EACC Math Lesson number 5, Ratio and Proportion. This is two really important concepts, working with ratios and being able to set up and solve proportions. They occur in a lot of things we do in almost all of your programs. You've got ratios and proportions. In the comic here, what they're trying to point out is that a 16:9 ratio is not the same as a 4:3. These are not proportional. So when you try to fit one inside the other, it's not going to work. Okay, so what is a ratio? Well, we're just talking about a comparison between two different things. They're usually numbers. For instance, if we count people in a group and we look at the ratio of men to women and we're told there are 35 people, 15 whom are men, then the ratio of men to women is 15:20. Notice that the expression, the ratio of men to women, the men part came first, so that's why we wrote the 15 first and the 20 second. That's real important when you're setting up your ratios. Ratios occur all sorts of business applications. We're looking down in sales, so ratios of people to jobs, all sorts of situations. Here's an automotive situation. We talk about gear ratio, where it's the driven gear over the driving gear. So the driven gear on this first one is 60, the driving gear is 30, and we always want to reduce, so that's 6:3 or 2:1. The ratio of those gears is 2:1. The second one, the driven gear is 36, the driving gear is 9, so that's a 4:1 gear ratio. Here's a culinary example. Number 1 here, they're giving us some ratios of doughs and batters as far as the liquid in them, the flour, the egg, the fat, and the sugar. So in the first one it says, write the ratio of egg to flour in the pancake batter. Well, if we look down at our pancake batter, which is down here, egg is in the maroonish color, so that's 1. And the flour is in the red color, so that's 2, so our ratio is 1:2. Write the ratio of liquid to fat in the biscuit mix. So looking at our biscuit mix right here, the liquid is in the blue, light blue, so that's 2. The fat is in green, so that's 1, so that ratio is 2:1. And I've been writing them using colons. We could write it in a fractional form also. Okay, example number 3 here. The Packers lost 8 of their first 10 games they played. Write the ratio of wins to losses. Now, you got to be a little bit careful with these. They played 10 games. They lost 8, so that means they won 2. So the ratio of wins to losses, they won 2 and they lost 8, so that ratio is 2:8, and we're going to reduce that to 1:4, or again we could write it as a fraction, 1:4. Okay. Proportions then are simply 2 or more equal ratios. If you look over at the picture on the right, human beings' bodies are proportional. In other words, the ratio of the hand to the forearm, in this case, is 1 to 1.618. That ratio would be the same in just about every human. Okay. So if I write out a proportion, let's say I have the ratio of 2 to 4. Well, a ratio that's equal to that is 1 to 2. We now have a proportion, 2 equal ratios. Okay. After we set up a proportion, we need to be able to solve it for unknowns. And this is called the means extremes property. And just simply remember that you're going to be cross-multiplying. Most of you know this. But here, if we have a true proportion, if A over B is equal to C over D, then the product of A times D is equal to the product of B times C. So in our proportion here, the product of 10 and x, or 10x, is equal to the product of 4 and 7, or 28. And then if I was to solve this for x, I would simply divide both sides by 10. So x is 2.8. Okay. All right, so here's a little problem solving. Notice on the right over here we have a disproportional picture of Alice in Wonderland. Her neck is a little bit out of size there. Okay, so in this problem we're told that a 380 cubic centimeter sample of titanium has a mass of 1,710 grams. Find the weight, or the mass, of a titanium sample that has a volume of 532 cubic centimeters. Okay, so there's our first ratio. 380 cubic centimeters is to 1,710 grams. Now, when you're setting up your proportions, it really doesn't matter how you set up that first ratio. Just remember to keep things in the same order. So in the first one I have cubic centimeters over grams. So I need to put my cubic centimeters here, and I don't know how many grams that is, so that's my unknown. So cross multiplying, we get 380x is equal to 1710 times 532, which is 909,720, 909,720, and then divide both sides by 380. So we get x is 2,394 grams. So again, setting up your proportion, it really doesn't matter how you set up your ratios, just remember they're in the same order. Cubic centimeters over grams, cubic centimeters over grams. All right, a little true or false. The ratio of 40 men to 30 women can be expressed as the ratio 4 to 3. Well, if I have 40 to 30, yeah, I can reduce that to 4 to 3. So this one is true. Number 2, the ratio of 3 feet to 2 yards can be expressed as the ratio of 3 to 2. That's false. And the reason that's false is we need to have both these in the same units of measure. Okay. Number 3, the ratio of men to women in the Chamber of Commerce is 3 to 2, and there are 20 men, then there must be 30 women. Here's one where the order is important. The ratio is men to women, so men is 3 for every 2 women. So if there's 20 men, there can't be more women. So that's a false statement. The ratio of 1.5 to 2 is equivalent to the ratio of 3 to 4. Yes, that is true, 1.5 over 2. If I divide 3 and 4 by 2, I'm going to get 1.5 over 2. So that is a true statement. Number 5, a statement that 2 ratios are equal is called a proportion. That's true. That's how we define proportions. Number 6, the product of the extremes is equal to the product of the means. That's true. That's how we solve proportions. Number 7, the ratio of the height of a 12-inch cactus to the height of a 3-foot cactus is 4 to 1. Well, let's see. 3 foot is 36 inches, so is 12 to 36. That's not going to work because here, 4 to 1, we want the 12-inch to the 3 foot. We want the smaller one first. So no, that's got to be a false statement. Number 8 is 30 out of 100 lawyers preferred aspirin and the rest did not, then the ratio of lawyers that preferred aspirin to those who did not is 30 to 100. Well, you got to be careful here. 30 out of 100 means that 70 did not. So the ratio is 30 to 70, not 30 to 100. So that would be a false statement. Okay. A firefighter truck can hold 3,000 gallons of water. A firefighter can deliver 160 gallons of water every 2 minutes. How much water will be delivered in 10 minutes? Okay, so they're giving us a problem-solving situation here, and one that obviously uses ratios. So the ratio we can deliver, or the firemen can deliver 160 gallons of water every 2 minutes. So 160 gallons for every 2 minutes, and I'm going to reduce that to make things easier to work with. Divide both these by 2, so that's going to give me 80 to 1. So how much water, so the water is on top, can be delivered in 10 minutes? So cross-multiplying, I get 1x is equal to 800. And so that was gallons, so let's label that at 800 gallons. Number 10, How long will it take for the firefighter to empty the tank? Well, again, we're emptying the tank at a ratio of 80 gallons for every minute. We want to get rid of 3,000 gallons. So cross multiplying, we get 80x is equal to 3,000. Divide both sides by 80. And so we get about that x is 37.5. And so that would be minutes. Okay, moving along then. All right, number 11. To estimate the number of catfish in her pond, a catfish farmer caught, tagged, and released 30 of them. Later, only 3 tagged catfish were found in a sample of 500 to estimate the number of catfish in the pond. Okay, so biologists actually use this method to estimate the number of certain kinds of fish in lakes and streams. All right, so in the first part, they tagged 30 catfish. So there were 30 tagged out of the total population. Well, we don't know the total population, so that's our unknown. We do know that they got 3 tagged ones out of the 500 they caught. Okay. So again, cross multiplying, we know that 3x is equal to 15,000. Divide both sides by 3. So this pond holds 5,000 catfish, approximately. It's a lot of fish. And number 12, they're about 2.54 centimeters in an inch. What would a 3-foot, 4-inch pipe measure? Okay, so our ratio is 2.54 centimeters for every 1 inch. We got to be careful here. This measurement is in feet and inches. So I know that there are 12 inches in every foot. So I've got 3 of them there, so that's 36 inches, plus then the 4, so I've got a total of 40 inches for this pipe. So how many centimeters then are in 40 inches? Well, cross multiplying, we get x is equal to 2.54 times 40, which gets us 101.6, and that's centimeters. All right. Again, you've got some problems to work on. If you've got questions, please let me know. I'll talk to you later.